Let's do a few problems where we convert a definite integral into a Riemann sum. So this is my definite integral here. And I always like to start with delta x. So delta x is equal to b minus a over n. Well, in this case, my b is 6. My upper limit of integration is 6. My lower limit is 4. So I have 6 minus 4 over n. And so it's 2 over n. And I leave it with an n because I know that my Riemann sum is going to look like this. Riemann sum is always going to start with this kind of notation. Limit as x approaches infinity, I or j or k is equal to 1 to n. It's always going to start with that. So I'm going to leave my delta x as 2 over n. So that is going to be my dx. Now I'm going to look at the integrand, okay, the part of the function, well, the part of the integral that is that is being integrated, the function here. And I'm looking at that and I'm saying, well, what in this is changing? Well, it's the x that's changing. And how is it changing? So I'm going to write here. This is what's changing. This is what's changing. And whatever it is that's changing, it's being squared, and then it's being multiplied by 3. Now at the end of that activity, I'm going to add 5. But that's not changing. That 5 is not changing. The only thing that's changing is my x in here. And that's going to be squared and then multiplied by 3. So where is the x? Where is the x starting? Well, the x is starting right here at 4. So my x is 4 plus, remember, each time that I move over a notch, I'm increasing it by 2 over n. So it's 4 plus 2 over n times I. Each time I increases a notch, I move it over 2 over n. So my Riemann sum for this this integral right here looks like the limit as n approaches infinity of the sum I equals 1 to n of 3 times 4 plus 2ni squared plus 5. That is the height of each, because that's the function, that's the height. And then I multiply it by the width, which is 2 over n, my delta x. Let's try another. So again, I'm going to start with my delta x. And delta x is b minus a divided by n. So it's 7 minus 2 over n. Each time I move a little notch over on my x, it's going to be 5 over n. Oops, 5 over n, not 5 over 2, equals 5 over n. What is changing in the integrand? Well, it's just x that's changing right here. And what's happening to x? Well, x is being squared, and then it's being multiplied by 4. Actually, let me take that back for just a second here. My x is, I'm subtracting 1 from my x, then I'm squaring it and multiplying by 4. Where does my x start? My x starts at 2. And every single little notch, it goes up by 5 over n times I. So this is the x value starting at 2 and going up a little bit of notch every time. I'm subtracting 1, squaring it, and then I'm multiplying it by 4. That's going to give me the height of my rectangle. And then I'm going to multiply this, the height, times the width, which is simply my delta x. And I am finding the limit as n approaches infinity of the sum of this from I equals 1 to n. Let's try one more. Again, I'm going to start with what is my delta x. So delta x is b minus a over n. So I have delta x equals 4 minus 3 over n. My delta x is 1 over n. What is changing in the integrand? Well, this x is changing, and that x is changing. So what I'm doing here is I'm taking this x, whatever it is here, and I'm squaring it, and then I'm multiplying it by 6, and then I'm adding to that. Well, I'm just taking my x, and I'm multiplying it by 3. Where does my x start? My x starts at 3. So inside here, I have 3 plus, well, every little increment is delta x, right? So it's 1 over n times I. It's the same x, so it's going to be 3 plus 1 over n times I over here too. So this is the same as 6x squared plus 3x, starting at 3 and ending at 4. So I'm taking this whole thing right here, and I'm setting the limit as n approaches infinity of the sum of I equals 1 to n. And I'm taking this whole thing, and every time I move it over another little notch, I'm multiplying it by 1 over n, which is the width of the different rectangles.